5. So if we have a group, then prove that a star b squared is the same as a squared b squared for every ab. No, if that's the case, then G is abelian. Okay. So a couple people got confused about this. This is just a shorthand, right? They're just saying we're going to use this little 2 to mean multiply it by itself the way that, the way it normally means. So it's not like any kind of new anything. They're just saying, that 2 is short for multiply it by itself. So, which means that this equation is short for really this bigger equation. This multiplied by itself, and then a squared, which is a multiplied by itself, and b squared, which is b multiplied by itself. And then, as I like to say, since we're in a group with associativity, there's no point to writing parentheses. We might as well just write this. Okay, so why does this mean that it is abelian? Well, check out how similar these two expressions are to each other, right? They both start with an A. They both end with a B. The only difference is in the middle. So if we could somehow isolate that middle part, then that would be actually exactly what we need, right? That B star A equals A star B. And there's a super easy way to do that. All we got to do is cancel things out using inverses, right? So on the left, let's multiply by A inverse. That way it will cancel with the A here. And on the right, let's multiply by B inverse. That way it will cancel with the B. And then, of course, we'll do the same thing on the other side. Multiply by B inverse on the right. And then, boom, 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 boom. We get B star A. Let me try that a little neater. You could put a line in between with like the identity elements and stuff, but ultimately they cancel. And you get that. Boom, right? And it was true for any A and B, right? This was true for every A and B. So we ended up with this being true for every A and B. And that's exactly what it means for G to be abelian. So that's all there is to number 5.